We're going to continue with our PyTorch CNN Convolutional Neural Network Part 3. We're gonna probably get the AI model to train today. We're going through every single PyTorch tutorial that's available to us, and we're going to become PyTorch experts. Let's do this. Let's become PyTorch experts. We've got our class that we built here with a whole bunch of fun functions in it. Some nice little debug functions to check to see that our data looks nice and clean. We've got our norm vectors, which is going to normalize all the data across the different image types. So that way, when we're converting the images from, 0 to 255 per color channel, we're going to convert it. Hey, Neva, good to see you, Steven. Hey, welcome on in. We're doing convolutional neural network today. We're gonna make it work. We're gonna train it today. Essentially, the last couple of streams, we built it up. Now we've got the full thing. We've got our data. Now we just got to run through the optimization steps, which is, the learning phase. Let's get it happening. I'm excited about this. I hope you've had a good set of days recently. Or someone was in here. They mentioned you. Neva. Hey, have you heard of Neva? Yeah, they said they were related to you. They said they were related to you or something like that. I can't remember exactly what they mentioned. They said, oh yeah, Neva, you know Neva? I'm like, yeah, we know Neva. What are you saying Neva for? All right, so let's get into this. So we got our batch color channel width and height. Oh, maybe my kid brother. Yep, maybe. So now we're going through the tutorial. We got our classes, our labels, our output data. We showed the images. Let's run it to make sure that we're in a good state here. So let's run this really quick. Okay. Should pop. Yep, there we go. So we got a pop up here. Some image data right here. Obviously a car, a bird, a dog, and a cat. That's actually a good combo. Did I label it correctly? Am I a human? Car, bird, dog, cat. Yeah, there we go. The layer norm thing, is that used in training? It is only in training, yes. And I know you might have spotted this. You don't necessarily need to put it inside of a class like this, although we did. Hey, Zachary Hamilton, hey! I posted the line I was trying to get. So this is what we're doing that for norm of the vector of. I'm just calling it norm vex. You can call it whatever you want. I'm just using it right here. So that way, this actually is really useful. So that way, it makes your data show up much more evenly across the available bits in a floating point value. Oh, so you're running this as a pre-processing. Yes, exactly. Pre-processing. You know it, because when we want to convert those color channels into, 0 to 1 in a floating point number, I want, it's got to be smooth. You want smooth gradients. It's what you want in AI. Everything want to be smooth. It's all got to be smooth. Optimization phase. Let's do this. Train the model. Okay. I'm pretty sure we're at that point now. Training your PyTorch model. I knew it. All right. Well, I read ahead. I read ahead. Let's put all the pieces together and train the model. Do I have everything I need here? We don't need to redo this. Okay, so they're redoing everything. Oh, they're normalizing everything to 0.5. Okay, you could do that too if you want. I like this function right here. That's pretty nice. So we're loading the data. Let's also load in our test data set. Let's do that as well. Let's make that happen as well. So we've got our test data set around here. All right, so this will be self.testSet equals. All right, test data. Let's do test data. And this is training data. Like that. Okay. We'll copy paste this. That's data loader. This will be test loader. Test loader. And this will be the test set. This is train false. So that gives us our data that we want. Also, I want to do a one-hot encoding for this because I know it's going to be better. You get better results with one-hot encoding. It's going to give, because otherwise it's just going to give you a big number and it's not great. It's not so great. Need a one-hot. Self.oneHot equals a, can we do how do we do that? We need to convert a tensor into a ones. So we need a ones, and then we need to update the ones with the length. Okay. Torch dot ones self dot classes. Where's that at? Class number of classes. Okay. Like this. Let's construct it again. We'll construct it from scratch. So let's do this. Python import torch, and then we'll say torch dot ones, and we're gonna say like it's 10, right? Okay. Let's do zeros instead. Zeros like that. Can we do zeros with an E? No, it doesn't like that. Okay. And then we need to update one of the indexes with the actual class. So how do we do that? We did it before. Class imbalance with solving either duplicating the smaller class or just using all the samples of the big classes. So what we're doing is we've got a class system here where we've got a bunch of pictures. We know what their possible labels are and the answer positions. When we get the label data loading from our training set here, right here. So what we want to do is convert the output from the labels, which is going to, like, for example, right here. I don't know if you can see that on the screen pretty well, but we're going to get our labels and it's going to return numbers. And we need to reference those numbers with our classes because it's going to be the index. However, when we're training our model, we want to train on the output with numbers between 0 and 1. In order to do that, you need to create an array. That array needs to have the same number of classes in it. So we're going to have an array that looks like this right here. And only one of the values is going to be active. Only one of the values. So A equals A. So you say 4 equals 1. And then you see, for example, you can see here that there's a 1 right there in the middle. For example, right there in the middle. And that would be, in that case, number 4 would be, in our class section, would be 1, 2, 3, 4. Or 5, actually. It would be the deer. It'd be the deer. You think numpy.oneHot method? Is there a oneHot method in numpy? Is there? We're using PyTorch, though, so we don't want to jump from a tensor to a... We want to keep everything in tensors. Steven, you may want to do a torch class equals 4. Oh! Okay. Yeah, I like that approach. Never. All right, let's do that. Okay. Yeah, torch has oneHot. Does it? Torch has oneHot? Let's see. Let's see. Torch.one. Hot? How do we see that? All right. Dir torch 1. It has ones like, and it has ones as clone, lazy clone, none type. Hey, Lauren, thank you. Hey, Lauren, good to see you. It's been a while. Hope you're here. 1_hot. Got it. 1_hot. Let's try this. Torch 1_hot. _hot. Lauren, thank you for the membership. Good to have you back. It is not torch. Has no attribute oneHot. No attribute oneHot. Is it .nn? No. Is it transform? Is that what it is? Torch. Torch.transform. Transform. Z. Wait, is it not? Wait, transform. All right, it's not that. What? Weird. I don't know about that. Yeah, it's weird. Hey, we're gonna find out though. Don't worry. Where's our transforms at? Oh, torch vision. All right, let's try that. It might be here. Okay. Copy that. Bring that back over here. Yep. All right. So transforms dot dir. Let's do dir. All right. What do we got? I don't see it here. I do not see it. Maybe it's in torch vision. Torch vision. Import torch vision. Okay. I don't see it there either. Where's the one? It would be great to use it. If the framework has it, we want to use it directly. Anyway, for the solution to work, so who cares? Yeah, we're gonna try. All right, so we're gonna do torch.tensor, and we'll say x equals class for x in range. We'll say 10, like that. Okay. One. We'll try the true false. We'll try the true false. And our class is going to say 4, for example. Okay. Tensor, comma, d type equals torch.float 32. Okay. generator expression, parentheses. Oh, it's got to be parenthesized. Can we do it in an array like that? No. It seems like we should be able to do that right there. That seems like that's something that should be able to be happened. There we go. Okay. Hey, there we go. Now we're into it. That is a really nice approach. Okay, Neva, thank you. We got it. We got it, you guys. What if we delete the D type? It's going to automatically give us... Oh, so it's going to do true, false unless we do D type. There we go. So we just created ourselves a nice little transform right there. We do have to go a step further, though. We do have to do a step further. So I want to bring this down over here. Paste that in. Okay, so this is just part of it. That's part one. We got to do a lambda now. Where's the transforms at? All right, so transform.lambda. All right, so this will be a... No, we need the number of classes here. This will be right here for the range of 10. And this will be our although, wait, yes, okay. Class. Well, let's open this up. We've got another file around here. Hey, ask you later. Good to see you. Welcome on in. Happy Wednesday. We're building our convolutional neural network. We're becoming PyTorch experts. We're gonna do it. We're gonna become PyTorch experts, you guys. Yes, exactly. Lambda X. You got it. It got it. Data. Yes, it's called custom data set. All right. So this is our lambda right here. Okay, let's make sure we got that. Where we got that. Vision transforms, and we're gonna do transforms as transforms, and then we could do transforms.lambda. Okay. So this is where we're gonna get our lambda at, I believe. All right. So .lambda right here. Okay. And I believe we can simply, we keep it really simple, right? We just do lambda. It takes one parameter, x, colon, and then we just return this right here. The torch tensor. I think that's it. Like that. Boom. Done. Let me make it pretty so that way we know what's going on here. All right. Bring that over here. And then we're going to put our list comp here. It's not called class. It's going to be called... Oh, we can't do X here. We have to call this CLS. No, we got to call this something different. Label. I'll just call it label. Let's just call it label. Right there. Label. X equals. Perfect. Okay. Let me pull this back over here. Nice. Now, here's our one hot. Facebook built PyTorch as well. That's where PyTorch came from. PyTorch comes from Facebook, right? I assumed they would want to use PyTorch more. Okay, let's keep going, you guys. So we've got our one hot, and we need to do our transform. What was it called? There's a different kind of transform here. It's called transform target. Okay. The transform target equals self.one hot. Like that. Okay. Same here. Okay. Let's load this and make sure it works. No, they use PyTorch, yes. Oh, yeah. Facebook uses PyTorch, yeah. Facebook is using everything like React and PHP and Haskell for the same website. Haskell, ... Really? Are they using Haskell? Let's try this. Is it gonna work, you guys? Or are we gonna hit an error? All right, we hit an error. All right, got an unexpected keyword, transform target. So it might not have been that. Let's find out what it's actually called. It's going to be custom data transform. Where is that at? Yeah, a target transform. Okay. I inverted the words. Let's try that. Like this. Okay. All right, let's try it out. Let's see if it works. How's it going there, XD? Good. We can't do show images if we transformed it that way. We need to do an argmax now. Let's update this. Let's update our image show for argmax. Labels. Let's see, labels equals argmax. Let's do argmax, you guys. XDev, thank you for subscribing. Welcome on in. This is the channel for software engineering. We're building ourselves PyTorch tutorials, convolutional neural network today. And we will learn every single tutorial live on this stream. That's the plan. Every tutorial, all of them. All the PyTorch tutorials. We're going to become PyTorch experts. That's the plan. Let's do this. The spam filter has Haskell, I believe, which is like Lamau. Interesting. Yeah, I'm excited about it. This is one thing. I've done a lot of AI in the years, mostly from scratch, because I did it before the the frameworks existed. The frameworks have all the math built in for you. You just need to know what methods to call and how they work together. That's why we're learning PyTorch. Let's make it happen. Oh, nice. Yeah, I think it's great. All right, so we need to do argmax here. Can we do labels? Labels dot argmax. Can we do that? Is that something you can do? I don't know if you could do that. It's probably not. It's probably gonna be like, no, you gotta use torch.argmax. I think so. Yeah, it doesn't like that. Okay, let me print that out. Oh wait, no, that looks, all right, all right, labels, no. Okay, let's print labels and return so we don't get the error. We'll just return straight up like that. We'll do before and after. Before and after. This is how you debug in the real world without AI. That's also something that we do on this channel. Obviously, we're building AI. We're doing it as a human, though. We're doing it as a human. That's really odd. It printed both. It actually worked. It just didn't do anything. Torch. We might have to do a list comp. Argmax. Labels. Like that. We did it. We've got all the correct data. Now let's continue on with our training. So we've got our classes, we got our test data, training data. We did the image show already. Obviously, we don't need to redo that. Data, iterator, show image, all right. That's what we just did just now. This is our model, so we've got a different model here. So this is our model right here. We called it Lynette. They're calling it net here. Wait. They did a pool here. I like this idea. So wait, they're doing pool 2 at the same time. They changed it. This is what our model looks like here. However, we didn't get the activations and we didn't do something else. Let me bring the forward up top so we can read the forward a little bit better. This is what our forward looks like. Our forward is right here. This is ask the AI to answer based on input. This is like the input. For speed, go native. Yes. So let's do our optim equals torch.optim. What was it again? Oh wait, hold the phone. I don't want to use. Oh yeah, stochastic gradient descent is fine. We can do that. SGD, and we can put the. Where is that at? So optim is. Do we have that up here? Okay, torch to optim. Okay. Oh wait, we're doing it right. Optim. Yeah, we're making things work. It's working. Oh, you notice the keyboard below? Yeah, so got a keyboard right here, so you can see when I'm typing. Model. There's now something called vision transformers, which gives you a little bit different approach. We're going more the traditional route because we're going to make sure to learn all of PyTorch, becoming PyTorch experts. Become PyTorch experts with me. Let's do it. All right. So we're going to running loss, which I'm just going to call the cost, and we're going to enumerate our data loader. So let's do this. All right. So let's see, data, comma. We'll call this in features. We're going to call this features and labels. So features right here, this feature segment, that is the images. This is going to be the images. So that's features, images. Labels are going to be the actual, what they actually are. Is it going to be a cat, a dog, a deer, a frog, a boat, a car? It can be a lot of things. Like transformers are more flops than you would think. CNNs are nice and fast and learn well with less data. Okay, our transformers are going to be a little bit more advanced than in that case, yeah. Arguably, VIT is worse performing according to some papers that counted flops again. Here's what we're going to do, you guys. We're going to make it different. We're going to take a different path. We're just not going to have this. We're going to get rid of that. Okay. So this will be Lynette.train. And instead of saying return, we're going to say break. Okay. This is our training phase. Here we go. Wait, did I miss some stuff up? Yeah, okay, so we don't have self anymore. So this is going to be Lynette. There we go. Like that. Perfect. Okay. Oh, did we fix it? Oh, we fixed it. All right, perfect. All right, you guys. All right, we're on the right track now. Okay, so optim zero gradients is going to be able to optimize, turn off the gradients for our back propagation. No errors. Hey, we're looking good. Nice. Yeah. I was like worried about it. I'm like, oh no. We only have like, what is it? 17 minutes. We got 17 minutes. So I think let's go through one training batch and find out here. We should get something on the screen. It should look good. Oh no. Okay. Given one group weights expected input have 1 channels but got 3 channels instead. We are only supposed to have 1 channel. Did we mess that up? Did we reduce it? We didn't reduce it right. The villain music too. I know, Forerunner. I know exactly. Are you using cross validation? Yes, we are. Well, we're using cross entropy loss. Cross validation is. We don't need that. We should do the cost. All right. So let's calculate the loss now. Equals our loss. Linet.loss, and we're going to do our out and labels like that. Let's print the loss and break. There we go. All right, so we should see a floating point number. It will be really exciting. What's Linet? It is my name for a computer vision model that's going to classify and be able to identify pictures of 10 different classes. 10 classes. The classes are going to be right here. It's a plane, or, right, see, it's a plane, or car, or bird, or cat, deer, dog, frog, horse, ship, and truck. So that is the classes. And we're calling it, let's see, Linet, right there. Linet, right there. Okay. So this is our optimization phase. Let's make this pretty. So this is like important. You know, we know this is important. Make some pretty important stuff here. All right. Paste. And to learn here. See, look how simple this part of the code is. It's only a few lines of code. If you were to look at the rest of it, all the rest of it is data preparation. It's ridiculous. And this is the actual AI learning part. We haven't finished yet, so we have to calculate the gradients, and we need to apply the gradients. So our loss.backward. The backward? Yeah, backward. Calculate gradients. And then we need to optimize. Optimize.step. Apply gradients to model weights. Like that. Do you save the best parameter somewhere? Hey, yeah, this is a lot of fun. So what you can do is, when you're building your model, initialize the parameters as random parameter initialization. Then you shuffle your data. And now and then use stochastic gradient descent during your training phase. Everything's randomized. So you've got this nice big fuzzy bundle of data that's going through. Every time you train the model using this approach, it's going to give you a different model output, which is pretty neat. I think it's pretty neat. That means that you train 100 models, one of them is going to be better than all the others. If you train it 100 times, one is going to win. So you can do a whole bunch of fun things, training the model 100 times and saving only the best parameters. We know about specific parts of the brain. We sure do. I knew it. You use fuzzy logic in your kernel? Nice. You're building it proper. All right, you guys, is it going to work? Is it going to work? I think it will work. I think it'll work. Oh, there it goes. Okay. Here you go, guys. Now here's the ultimate question. Will it learn? All right. Will the loss drop below 1.0? That's the question. Will the loss drop below 1? What do you guys think? I think the answer is yes, because we've got enough data. and we've got the correct model shape. It could also explode and go the opposite direction completely. It might explode up to 100 or infinity. So let's do epoch, batch. Let's see here. Oh wait, there's a problem here. I see a problem. We need an additional iterator. We need an additional iterator, you guys. All right. Wait. We're gonna fix it. We're gonna make sure. We're gonna do everything we possibly can to make sure that your correct answer is gonna be yes. It will be. I believe in you. All right. So we have to do one thing because the loss might not go below 1 because it's only gonna go for like 4 epochs or something. How many epochs? Is only gonna do 10 training batches. That's the number of batches. We need to do epochs. We got to do epochs. So we're gonna have to enumerate. We got to enumerate. 1 second. We're gonna make it. We're gonna make it work, you guys. We're gonna make it work. Let's see if we can make it a little bit better. Now I'm going to be moving these items into the. Where is it at? All right. So we're gonna be moving these items to device, and we're gonna define the device. So let's do this. Self dot. Let's grab this. We're gonna grab it from here. Device. Right here. Okay. And we're gonna put this up here. We'll put it over here. Right here. So we got our device. We got our accelerator right there. We got our accelerator, and then we're gonna move the model and all the data over to our accelerator, so that way it goes faster. Okay. Device right there. Perfect. Okay. Okay. Let's make it go faster, you guys. Let's make it even faster. So the net dot 2. Wait, was it? Is it called 2 device? Yeah, I think it's just dot 2. What's dot 2? Device. Like that. Okay. Then we need to do the same thing for our images and labels. All right. Images equals images dot 2 device. Like that. Oh wait, we already did that here. We don't need to redo it. Whoops. Okay. Dot 2 device. Like that. There we go. I think that's it. Okay, that should do the trick. Batch. All right, so we'll say batch equals 0, and then we'll say batch plus equals 1. So we increment our batches here. I'm gonna put this over here though. If batch mod 100, if not batch 100, print it. Like that. So that way our screen doesn't explode with a bunch of stuff. So we can see it a little bit. Although I want to see a better learning. I want to see better learning. And is that batch not big enough? The batch isn't big enough. I need a bigger batch. Let's go batch size of 64. Let's go bigger batches. Gotta get the bigger batches going. Here we goop. Yeah, here we goop. All right, now we're into it. Now we're into it. Okay, our loss isn't going down as much as I want it to, although it does kind of look like it's going down, just not nearly as much as I want it to. How's it going there? Oh, we made really, ooh, there's a really good one. There's like a 0.85 right there. You see that? There, right there. Nice, really low one. That's a really low one. I want it to consistently stay below 1 though, and it keeps popping up. It keeps popping up, which is a little rough. I want it to decrease a lot more. Maybe we can increase the learning rate. Let's try this. Let's go a smidge higher. Make it increase just a smidge. Let's do 0.5. You need a lower learning rate. Oh, it's got to be even lower? Okay. And regularization. I suppose so. I suppose so. Yes. See you when you go live tomorrow. Hey, Selby, thanks. Sounds good. 5 times. 5 times more. Okay, I'm gonna close that and I'm gonna try just a smidge lower. So we're gonna go lower. We're gonna go lower, and we'll increase the density to 256. So it's a bit more, and then our batches will be 128 because we've got the power. We got the power. Also, larger batches can help. Hey, we just did it. We did larger batches. There you go. All right. Yeah. Okay, it starts out high at the 2s. It went dropping down the 1s now. All right, seeing a little bit more smoother now. A little bit smoother. You like learning? Me too, Sally. Me too. Hey, how's it going there, Gold Prospect King? This is alien to me. Coding. Is it? Is it? Well, that's what we do here. We do the coding. And we're training an AI on convolutional neural network. We succeeded. I'm liking the numbers well enough. I'm liking them enough that we're at the point where I can say, we did pretty good. W and it got a keyword momentum. It doesn't like momentum. All right, fine. We're going to get rid of momentum. Let's do that. Well, fine. Here you go. There's no momentum for you, Adam W. Had to be a pain to print mean loss per batch instead of just the final. So it's less noisy. It is kind of the mean loss. Here, I'll show you. Here it is. It's kind of the mean loss, yeah. What we could do is we could do true mean instead of the average, running average. We could do the true mean. So we could do that. Let's do that real quick. All right, so let's do losses equals array. And we'll say losses dot append loss. And then we'll say sum losses. Here we go. Okay, like that. Let's try that. Although I was looking, I've seen a lot of zeros there. I'm seeing a lot of zeros. I'm liking that. I'm liking that. Uh-oh. I forgot part of the trick. That the cost is not going. It's going the wrong direction. All right, 1 second. Divided by len losses. Okay, now we're good. Now we're doing the mean. Okay, here we go. Oh, just kidding? List and int. Okay, fine. Float. How about that now? All right. You're welcome. Oh, thank you. Appreciate it. Oh, wait. What are you talking about? List and float. Oh, I see. I'm being silly. Hold on. There we go. Now it's going to work. It's going to work now. Right? There we go. This is the actual running loss. Ooh, it did improve. And look at that. Okay, that's way better. Thank you for... Who said that? Forgot to divide the len by losses yet? Who said that? Hold on. Wait. Dorothy. Thank you. Look. Roaring Markner. Oh, that's what I want right there. I like that a lot better. Thank you, Rowan Marknor. Thank you. You win. Gold star, Rowan Marknor. It's smooth now. Yeah, it is. Thank you. I mean, I saw something on YouTube. It claims that it can view your hidden password and inspect. Is that true? Yes, it depends. And found password and then leaves the quotations. And it should show on the screen for me. So there's a couple of ways to go about that in that case. There's a couple of ways. Do you mean Jack Doherty? I thought that's what you guys were talking about. All right, you guys. This is very satisfying. This is what I wanted to see. The average didn't go below, although there were batches that did go below 1, and I count that. What are we doing right now? Hey, Rival Sebastian, we just built our own AI model, and it's going to be a CNN, simple CNN right here. So if you see, there's our layers, here's our forward function, and we trained it on some sample data here that we loaded called the CIFAR 10 dataset, which is a bunch of pictures of planes, cars, birds, cats, dogs, frogs, horses, ships, and trucks. Things like that, cars and things. All right, you guys. The plan for tomorrow, we're going to be testing the training data. So we're going to train the model, and we're going to run it on test dataset and see how accurate it is. Obviously, it's going to take a little while to train here because there's a lot to train on, and it requires a lot of work. All right, guys, thank you so much for joining. We'll be back tomorrow. Appreciate it. See you tomorrow, guys. We'll be back tomorrow. We're going to be testing the model's accuracy. That's the plan for tomorrow. We'll be back. Bye, guys. See you tomorrow. Probably. Okay.